Hi guys, good evening everyone. Welcome to the session and welcome once again to the India's most comprehensive preparation platform, that is the BYJU'S Exam Prep. Yes guys, so we are live once again into the GATE Champion series. Yes guys, the GATE Champion series, which is a live GATE workbook for you. Yes, let me every time keep you reminded that in this GATE Champion series, we are covering up more than 500 technical questions specific to your branch. And yes, 500 questions live to be discussed, and 500 plus questions is like a workbook. Yes, so we are just producing one live GATE workbook on the YouTube. Right. Good evening AKG, Ravi, Ritu, very good evening all, and quickly update your friends that the session is now live. And in this particular episode of Signal and System, prior to this we have discussed Fourier series, continuous time Fourier series, continuous time Fourier transform, we have discussed Laplace transform, we have discussed Z transform, we have discussed the DTFT and the DFT. Now we are going towards actually DTFT and DFT. Right, let's get started. Yes, this is a brief intro about me in case somebody new to my session. This is your mentor and educator Rakesh. Secured All India rank 9th in GATE, completed my Masters from Indian Institute of Science, Bengaluru. Yes, it's been more than 12 years training, trained more than 50,000 students, and these are my major area of expertise. These includes my major area of expertise. Okay, right, chalo. Okay guys, so yeah, in case if you want to now take the next step towards your success in GATE, and if you want to prepare in the GATE preparation program under the India's best faculty team by BYJU'S Exam Prep, and you want financial assistance, yes, you can just appear in a scholarship test coming on just this coming Sunday, that is 18 September, morning 11 AM. And you get up to 90%. So prove yourself, earn your respect, earn your scholarship. The scholarship will be somewhere between 20% to 90%. You can get maximum up to 90%. Maximum up to the 90%. Yes, Ravi, actually that Laplace transform session PDF, it is, I took in which studio? It is not there in my mail. So just give me 1 day's time. Once I get free from this class, on which studio in the office I took, I'm not able to collect that. Okay. I thought I uploaded on the mail immediately, but it is not available in my mail. That is why I could not share it with you, but I will share it with you. Okay. Okay, I'll share it with you. Okay, so I'll just have to check why it is not there. Just have to check. Okay guys, now let's get started. And once again, we'll have a very quick review of the DTFT. Right. Okay, great AKG. Okay. Chalo, so once again guys, we are just first of all going to review the important points of the DTFT, first relating it to the Z transform. So last session we have discussed the Z transform. Okay Ritu, okay. Good evening Janvi. So we have discussed the Z transform in the last session. What is the Z transform? And there is a connection between Z transform and DTFT already we have discussed. Okay, already we have discussed, and let us talk about that. Okay, yeah, previous class lectures are available on the same channel Janvi. Okay, when we discuss Fourier transform, Fourier series, Z transform, Laplace transform, it is available on the same channel. So guys, Z transform was basically defined as the summation of xn z raised to the power minus n from n equal to minus infinity to the infinity. But then in general in the Z transform, Z is given by r e power j omega, where r could be anything based on the ROC. Based on the ROC. See Sandeep. In the latest syllabus, they mentioned Fourier analysis of discrete time signals. In the electrical syllabus also, Fourier analysis of discrete time systems. Okay, so definitely we can't say, yes, according to the syllabus, if we go Fourier analysis of discrete time signals, so it could be DTFS, DTFT and DFT all the electrical, we can have less chances of DFT question. But yeah, now according to the official syllabus, you read Fourier analysis of discrete time systems, discrete time signals. So of course that includes DTFS, DTFT, DFT, everything. If they say Fourier analysis, officially it includes everything. So yeah, you have to go through it. Okay. Chalo, so Z is r e power j omega in general. But for the DTFT, what is the DTFT? As we have discussed, DTFT is known as the Z transform evaluated over the unit circle. It is the Z transform evaluated over the unit circle. That is by putting Z is equal to e power j omega, because unit circle is known as mod Z equal to 1. Mod Z equal to 1 means R equal to 1. Modulus of Z is known as R. Okay. So then what is the DTFT formula? Okay, we have x of Z. Z is equal to e power j omega. is given by the formula summation of xn e raised to the power z power minus n will now become e power minus j omega n, and that is what is your DTFT formula. Okay, x of e power j omega, so ultimately it is a function of omega. X of e power j omega, so ultimately x depends on e power j omega, but e power j omega depends only on omega, na? So we also call it as a function of direct omega, that is a function of frequency Fourier transform x omega. Here it is. So x omega is summation xn e power minus j omega n. But also very important thing that we learned in the last class, that every z transform has a ROC. Every z transform has a ROC. Okay. So DTFT is equal to Z transform evaluated over the unit circle, and ROC is the region where Z transform is defined. So Z transform is defined only inside the ROC. Okay, you are calculating Z transform on unit circle, so unit circle should be within the ROC. Unit circle should be within the ROC, right? So if ROC contains the unit circle, then only the DTFT converges, otherwise the DTFT cannot exist. Now understand one simple example here. Understand one simple example here, everybody. Oh, what happened? Just a second. Yeah. Just a second, guys. Huh? Yeah, everything seems fine. Understand one simple example here. देखो ध्यान देना. कुछ issue चल रहा है. Okay, no problem. Now look into this. Suppose I give you an example, guys. Suppose I give you an example. 1 by 3 power n un. 1 by 3 power n un. What is the Z transform? What is the Z transform? We all know 1 upon 1 minus 1 by 3 Z inverse. 1 upon 1 minus AZ inverse, right? Okay, good evening, Rufina. 1 upon 1 minus AZ inverse. Acha. Now if I ask you, what is the DTFT? What is the DTFT of the same signal? Okay, what is the DTFT of same signal? So DTFT means you will just put Z equal to e power j omega. Okay, but first you will look into the Z transform, and what is the ROC? A power n un. A power n un ROC mod Z greater than 1 by 3. If mod Z is greater than 1 by 3, so mod Z can be equal to 1, na? Mod Z can be equal to 1, right? So DTFT is evaluated at mod Z equal to 1, and mod Z can be any value greater than 1 by 3, so equal to 1 allowed hai na? So now I will put down the value, so that I can say A power n un. A power n un has the DTFT 1 upon 1 minus A e power minus j omega, but with a condition. Now suppose if I give you 2 raised to the power n un, 2 raised to the power n un. Sir, let us start with the DTFT first. 2 power n un, DTFT तो रहेगा 1 upon 1 minus 2Z inverse, but with the ROC mod Z greater than mod A, mod Z greater than mod A is equal to 2. Now guys, if I ask you, tell me the DTFT of this. Now if I ask you, tell me the DTFT of this. Tell me the DTFT of this signal. तो कितना होगा DTFT? Now once again you will start substituting Z equal to e power j omega, and you will write down the answer 1 upon 1 minus e power minus j omega, 1 upon 1 minus 2 e power minus j omega. Is that correct? Is that the correct? No. For DTFT you need mod Z. देखो यहाँ पे you need mod Z equal to 1. But the Z transform is only defined for mod Z greater than 2. Mod Z equal to 1 is not allowed, right? Mod Z is greater than 2, so mod Z cannot be 1, and this is an incorrect answer. So what is the correct answer? What is the correct answer? For such signal, DTFT does not exist. DTFT doesn't exist. For such a signal, the DTFT doesn't exist. Dear, the DTFT doesn't exist. So remember, what I can say here is, if it is a very important signal A raised to the power n un, Z transform to exist karta hai with a given ROC, but its DTFT can be given by the formula, 1 upon 1 minus A e power minus j omega. 1 upon 1 minus A e power minus j omega, provided the modulus of A, there is some issue today happening, Modulus of A should be less than 1. If it is 1 by 3, DTFT bana. If it is 2, DTFT nahi bana. Okay. And these are some important for DTFT pairs. As in the previous class, I told you now, our focus is question. I will quickly go to question, but some basics and some formula we will set up so that with questions we don't have to revise. Okay, so that with questions we don't have to revise. So look into this, then we'll come back to this. So some important DTFT pairs I have listed for you once again. Okay, some important DTFT pairs. I'll show you the pairs once again. Very important point now is, ये तो समझ में आ गया. Okay, this is, I hope, understood to everybody. Now, very important point is the DTFT is always the DTFT x omega. It is a continuous function, and very important, it is a periodic function with the period 2 pi. Okay, no time and no requirement of proof here. It is a very simple proof although, but no time. X of omega plus 2 pi is equal to x omega. X of omega plus 2 pi is equal to x omega. The DTFT is always periodic with the period of 2 omega, and that is why while deriving, so entire information of the signal is contained within one period, rest is repetition. So while you derive back the signal xn, while you retrieve back the signal xn, that means when you take the inverse Fourier transform, it is necessary to integrate only for one time period. So we have the IDTFT formula 1 upon 2 pi. Dekho, in the continuous time domain, the formula you have seen is 1 upon 2 pi integral minus infinity to infinity e power j omega t d omega. But in the discrete domain, it is given by xn, the inverse Fourier transform formula 1 upon 2 pi integral x omega e power j omega and d omega for a period of t. What is a t? For a period of 2 pi. Let me specify here. That means this is the integration of the kind integration 0 se 2 pi, or commonly it is taken as integration minus pi to pi. Any one time period, and the total time period is 2 pi. The total time period is 2 pi. That is what it is. ठीक है जी? Okay. The DTFT exists. Again, the Dirichlet's condition, same as the CTFT also. In the CTFT, the signal should be integrable, absolutely integrable. The signal should be absolutely summable for the DTFT to exist. Okay, summation mod xn should be less than infinity. Important DTFT pair, so that we don't have to repeat with every question. Once again, I will say, as in the previous classes, if I am telling you a DTFT pair, I am telling you only those DTFT pairs which you should remember. Okay. Now, जिस पे ज़्यादा common question आते, that also I'll tell you. Delta n has every Fourier transform 1. That is the Fourier transform 1. Right, 1 has the Fourier transform 2 pi del omega e power j omega naught and 2 pi del omega minus omega naught. Cos and sine have the similar what you have learned, right? Cos omega naught n pi del omega minus omega naught plus del omega plus omega naught. Sine omega naught n pi by j del omega minus omega naught minus del omega plus omega naught. A power n un, just now I told you 1 upon 1 minus a power minus j omega for mod a less than 1. Similarly, a power nu minus n minus 1, यहाँ पे minus आएगा. It will have minus 1 upon 1 minus e power minus j omega for mod a greater than 1. Okay, n a power n un, a e power minus j omega upon 1 minus a e power minus j omega. Try to recall, relate with the Z transform formula directly, na? Az inverse upon 1 minus az inverse whole square. Okay, but mod a less than 1 is coming to satisfy that ROC condition. ROC should include the unit circle. Okay, un, no. 1 upon 1 plus j omega. ये summation property से related होता है ना? Okay, ये totally wrong आ गया है. Oh, sorry. I'll rewrite this. 1 upon 1 minus e raised to the power minus j omega plus pi del omega. Unit step, which is written as summation of impulse. Okay, so 1 upon 1 minus e power minus j omega plus pi del omega is the correct answer. Okay, plus pi del omega is the correct answer. Right. Next, rect of n by 2n. Rect of n by 2n, matlab we are taking a rectangle of the total duration 2n. The simple logic is, in the continuous time we were taking as rect of t by t, so that the rectangle is minus t by 2 se plus t by 2. But here, if you take from minus n by 2 se plus n by 2, problem क्या हो सकता है? Suppose somebody says, sir, n is equal to 5. So this becomes 5 by 2, but 5 by 2 is not integer, and a discrete time signal is only defined for integral values of time. Okay, that is why to assure that we define the rectangle as rect n by 2n. So that is a rectangle from minus n to n. 2n is the total base, so minus n to n, where n is an integer. This looks safe. And it has the DTFT as sine n plus half omega upon sine omega by 2. And then sampling an, it has the Fourier transform. This is same as the continuous domain result, pi by a rect omega by 2a. Okay. Then important DTFT properties, once again before I jump to the question, we are reviewing it quickly. Linearity, two signals are added, DTFTs are added. Time shift corresponds to exponential term, that is the phase term, e power minus j omega n naught, right? Frequency shift will correspond to phase term in the time domain, opposite sign ke saath, x omega minus omega naught, so it is e power j omega naught plus j omega naught n. Okay, next half period shift is nothing, put down omega naught equal to pi. In the frequency shift property, put down omega naught equal to pi or minus pi, both will give you the result. Okay, because e power j pi n, e power j pi is minus 1. So minus 1 power n xn is x omega plus minus pi. So we are shifting the DTFT by half period because full period is 2 pi. You will likha na 2 pi by 2 is pi. It is the half period. Time reversal same as the CTFT. If signal is reversed in the time domain, DTFT is also reversed x minus omega. Conjugation also has the same property. X star n has the DTFT x star minus omega. Time difference, this is just a consequence of the time shift property, nothing much important here. Okay, xn minus 1 is x omega, 1 minus e power minus j omega. Similarly, summation property is written in front of you. Then we have frequency differentiation, nxn, j d by d omega of x omega, same as CTFT. Right, two signals convoluted to DTFT multiplied, two signals multiplied to DTFTs are convoluted, but here there has to be a correction, it will be circular convolution. What here it is going to be? It is going to be a circular convolution, sir. Why? Because for any two periodic signals, linear convolution does not exist, only circular convolution exists. X1 and X2, DTFTs are always periodic. Modulation same as the CTFT, whenever any signal is multiplied by cos omega naught and its spectrum is shifted to higher frequencies centered at omega naught and minus omega naught. So all the, actually here you can say 70-80% properties are same as CTFT, few differences are there. That is why we have just revised and time to switch to the questions. Yeah, but before the question, let us also give, because some questions can be on Parseval's relation also. It also looks like similar to CTFT. Energy of a signal in time domain, summation mod xn square. In the frequency domain, 1 upon 2 pi integral mod x omega square d omega. Just like the CTFT. But in the CTFT, the limit is minus infinity to infinity. But here, in the DTFT, always the limit will be over a period of 2 pi. Because entire frequency information in DTFT is contained within 2 pi. Rest is repeated. Periodicity I explained you. We will take up the questions on all of this. Then we have the gain at low frequency or sum of series. Like in the CTFT, we have seen an application, area under the curve. Here we talk about summation of series, right? Because in the x omega, which is given by the formula summation of xn e power minus j omega n, as soon as you put omega 0, so e power 0 is 1. Okay, so you have summation of xn, sum of series will come up. Okay. So whenever you put 0 frequency, you get the sum of series. That is also known as the low frequency gain. Okay, that is known as the low frequency gain. Okay, this is summation of xn, which is like sum of all values x0 plus x1, even from negative side also, plus x2 and etc. What is the gain at high frequency? The gain at high frequency, so when you put omega equal to pi, since the DTFT is periodic, always remember, since the DTFT is periodic over a period 2 pi, okay, so low frequency means always omega is 0. What is the high frequency? It is omega equal to pi, because DTFT is always spread over a period of 2 pi, right? And that 2 pi we count from minus pi to plus pi. Minus pi to plus pi. So highest frequency is pi. This is important when we take some filter type question, identification of filter type question, right? Design of filter is removed from the syllabus, but you can identify the basic filters like low pass filter, high pass filter, etc. Okay, so when I put the high frequency, I get the sum minus 1 power n xn. That is like alternate, right? If you have x0, alternate plus minus, then minus x1, then x2, minus x3, plus minus, plus minus, plus minus. Okay, now let's eventually come to the question. Okay, just we wanted to revise few parameters before going to the question. So for the signal shown in the figure, find the following quantities without calculating DTFT. Okay, means property has to be striked, not detailed calculation. Okay, find x0. So what is the x0? Let us start with the A part. what is x0 is given by summation of xn. Okay, sum all the values of xn, sum all values of the given signal xn. So this is -1, then I 0, then 1, then it is 2. Okay, then 1, 0, 1, 2, 1, 0, -1. Okay, so this is cancelled. Last two answers cancelled. 2 plus 1 plus 2 plus 1, 6 plus 1. Answer should be the 7. Answer should be the 7. Rufina, just recheck. Yeah, some MSQ we are containing here, Sagar. Ravi agreed. And definitely some separate MSQ sessions also we have planned for you. Just stay updated to the channel, okay? There will be separate MSQ sessions also, dedicated MSQ. There only will talk about MSQ. But first let us revise and let us learn everything, because there we will only talk MSQ questions. Matlab whole subject should be cleared so that you can, comfortably attend all MSQ questions. Chalo. Okay, this part is 7. Next question. X pi. Sorry, let's come here. B. X of pi is given by gain at high frequency. X of pi is given by summation -1 power n into xn. Alternate plus minus, you have to only understand what is going to be the first value. So देखो, first value is -1 raised to the power -3. -1 power n is equal to -3, and the signal value is -1. And the signal value is -1. ये आपका first होगा. Okay, and then this first value is equal to how much? -1 power odd will be negative, so it is minus of -1. Are you getting it? Are you getting it? Okay, now every time I will not write -1 power n, so my answer will be, it starts with minus of -1, so then plus of 0, then minus of 1, ये value है 1, okay, then plus of 2, ये जो next value है ये 2 है, okay, -1 plus 2, then again -1 plus 0, -1 plus 2, -1 plus 0, minus of -1. Minus of -1. ठीक है, तो दिस इज नाउ माइनस -1. ठीक है, 1 0 हटाते जाते हैं, -1 2 -1 -1 2 -1 minus plus. Okay, this part is cancelled, this part is cancelled, this is 2. The answer should be 2. Check out the values. The answer that is going to come out is 2. Yes, Sagar, very good, correct answer. The answer is 2. The third question, integral x omega d omega. Now this is also directly some gate level type of question only. Integral x omega d omega कैसे निकालेंगे? Sir, what is integral x omega d omega? Now let us understand this next part. Okay, let us go to the C part. Let us go to the C part. Okay, integral x omega d omega. Integral x omega d omega from -pi to pi. This you have to relate. Actually, this you have to relate with the IDTFT formula. What is the IDTFT formula? Xn is given by the formula 1/2 pi integral for one time period, that is -pi to pi x omega e power j omega and d omega. Now when you want integral x omega d omega, ना energy नहीं है, energy नहीं है, ना, that is mod of x omega whole square, Saga. This is not energy. Good evening, Gautam. So you have to put omega equal to 0. Just put down omega equal to 0. You get integral of x omega d omega as 2 pi x0. Oh sorry, omega 0 नहीं, put down n equal to 0. I'm sorry. Put down n equal to 0. So integral x omega d omega is 2 pi x0. Right. Acha, when you put down any value of n, suppose n is equal to k. Suppose any value n equal to k, and then the question is integral x omega e raised to the power j omega k, e power j omega k, some specific value of n given here, then the answer should be 2 pi xk. Then the answer should be 2 pi xk. Okay. This is what is going to be used in the next two parts. Okay, so question number C is integral x omega d omega. Question number C, ये रहा. Integral x omega d omega is simply given by the formula 2 pi x0, and that is nothing but 2 pi x0. x0 का value 2 है, so the answer is 4 pi. Finished. Answer is 4 pi. That is finished. And then the D part, where the question is asking you, in the D part, question is asking you integral x omega e power j 2 omega. In the D part, question is asking you integral x omega e power j 2 omega d omega, and that is like putting a value of n equal to 2. So that is 2 pi x2. That is simply 2 pi x2. This is what is the value of, suppose k. K is equal to 2. So now this is equal to 2 pi x2. What is the value of x2? The value of the signal at 2 is 0. So answer for the D part is 0, sir. Answer for D part is 0. Next question. Next question. Integral x omega whole square d omega for one time period. This is related with Parseval's. So part number E is related with the parcels. Right. Integral mod of x omega whole square d omega. Right. When you divide by 2 pi, it is equal to energy of the signal. Right. When you divide by 2 pi, that is equal to energy of the signal. That is summation mod xn square. That is what is the Parseval's relation. That is what is the Parseval's relation. So if the question is only asking integral minus pi to pi modulus of x omega square d omega, so shift the 2 pi on the other side. This is 2 pi summation mod xn square. Now this should be further 2 pi summation mod xn square. देखो, starting with -1 का square is 1, then you have 0 square, then 1 square is 1, 2 square is 4, 1 square, 0 square, 1 square, 2 square, 1 square, 0 square, -1 का square 1. Okay, so this part is equal to 2 pi at 1, 1, 2, 4, 7, 8, 9, 10 and 14. 2 pi into 14. The final answer is 28 pi, sir. All of these are the good property questions of the good and simple questions of the property based on the DTFT. Okay, the 5 questions we have discussed here. Let us go to the next question. Everybody, now let us move towards the next question. Okay, chalo, next question here on your screen. This is the A part. That is the most simple, summation of xn, low frequency gain or sum of series concept. Okay, let's go. We have solved all these A, B, C, D, E. Let us move to the next question here. Here it is. The next question. MSQ question. MSQ question is here. Multiple select question. For the signal xn, okay, given to you, for the signal xn given to you, अच्छा इसी को MSQ में convert कर दिया है, I think. Okay, sorry, I've just converted. I just want to show you that same question I have converted. Same question I have converted into MSQ question. Nana, in the C part, Sagar Roy, we have used small x0. Understand the difference. Capital X is DTFT, small x is the time domain signal, right? It is the same signal of the last question. Okay, I've just converted to the MSQ. This is same as last question. Okay, so how MSQ question can be there? Okay, low frequency gain, was it equal to 6? No, that was equal to 7. Okay, you can again see here, na? ये तो cancel हुआ. Sum of series is sum of series 6 ही तो आ रहा है. Is it same as last one? Let me just check. Last one ये था -101, 2, 101, 2, 101, 2, 1, 0, -1, 2, 1, 0, -1. So A part में कुछ correction है क्या boss? Right, -101, then 2, 1, 0, 1, 2, 1, 0, -1. Okay, this part is cancelled, this part is cancelled, 2 plus 1. Guys, answer is 6. Answer is 6. Even you have not said anything, guys. Don't just blindly follow everything. Do the I always tell you, keep tally the calculation. Okay, I have to explain here everything in hurriedly. Okay, so just keep tallying the calculation. Option for the A part is 6 only. I think someone in the beginning gave 6 only. Someone in the beginning gave 6 only. Let me check who was that. Yes, Rufina I think gave 6 only. But then you also corrected because I said. ना एक जी इतना फास्ट भी नहीं है. Rufina gave 6 only, but she also corrected since I said. ऐसा नहीं हो चाहिए. You should trust your calculation always. First trust is the self-trust, nothing above that. First trust is self-trust, not only with respect to calculation, in general I am telling. First trust is the self-trust. So, this 6 ही है, okay? चलो, yeah. So, this is the correct option. Then, integral x omega whole square d omega, Parseval's question. What is the Parseval's answer? 28 pi. 28 pi मतलब option number D is correct, ये wrong हो गया. Okay, it is 28 pi, not 28, and this part is the capital X. ये तो typo error है, no doubt in that. Next, integral x omega d omega. What was integral x omega d omega? 2 pi x0. तो ये भी wrong है. The answer was 4 pi. The answer was 4 pi. Look at the C part. 2 pi x0. The answer is 4 pi. So this is also wrong. The correct answer is AD. The correct answer is AD. So just a MSQ question has been framed. Okay, so how a MSQ question can be framed from DTFT, I have just shown you with reference to the previous question only. All good. Next question now ready for you. Next question after this MSQ. A Fourier transform pair is given by 2 by 3 power n u n plus 3 as a e power minus j 6 pi f upon 1 minus 2 by 3 e power minus j 2 pi f. What should be the value of a? What should be the value of a? 2 by 3 power n un hota, so it's a direct question. 2 by 3 power n un plus 3, so it's a question on time shift basically. You can start with 2 by 3 power n un. You start your own calculation. You start with 2 by 3 power n un. What is the DTFT of this? 1 upon 1 minus 2 by 3 e power minus j omega. 1 upon 1 minus a e power minus j omega, because mod a is less than 1. Good evening, Piers. Because mod a is less than 1, so the formula is applicable. Now, time shifting n plus 3, as we have learned in the previous class also. Here it is n, here it is n plus 3. So you have to satisfy n plus 3. You have to first focus on n un. यहाँ का तो n plus 3 will be managed by calculations. So 2 by 3 raised to the power n plus 3. This is a power, this is an exponent. So it can be splitted easily. You should first focus on the time shift applied on the unit step. Okay. So when you apply time shift, you have to take both n plus 3, and now this will be equal to n plus 3. So this should be equal to e raised to the power j 3 omega, so that I get the sense that this is again a typo error. यहाँ पे plus आएगा. Okay, this is e power plus j 6 pi f. Okay, so e power j 3 omega, time shift property na, time shift exponential term, phase term, divided by 1 minus 2 by 3 e raised to the power minus j omega. Now I can split here 2 by 3 power n, 2 by 3 power 3 u of n plus 3 has the DFT e power j 3 omega upon 1 minus 2 by 3 e power minus j omega. Correct? Chalo. Now, what is this? This is to be shifted on right hand side. You get your DTFT for 2 by 3 power n u of n plus 3. 2 by 3 power 3 is a constant. To shift it on the right hand side, that becomes 3 by 2 whole cube e power j. Now put omega equal to 2 pi f. So 3 omega will be 6 pi f divided by 1 minus 2 by 3 e raised to the power minus j 2 pi f. That is what is given here. What is the value of a? What is the value of a? So this is what is the value of a. A is 3 by 2 whole cube, or that is 27 is divided by 8, and that is 3.375, numerical answer type question. 3.375 is the answer. 3.375 is the answer, dear. Okay, chalo, done. 3.375. Chalo, let's move ahead. Let's move ahead to the next question. Have a look into this question. A system with the transfer function hz, okay, has the impulse response, IR is impulse response, defined as h2 equal to 1, h3 is equal to -1 and hk is equal to 0 otherwise. So what is the hn? What is the hn? What is the hn? Okay, it has only h2 and h3. So what is the value at the origin? That is also not there. That is 0, then 0, then 0. Okay, नहीं यहाँ पे आ जाएगा 1. This is 0, 1 and h2 का value 1, h3 का value -1 and rest all is 0. Rest all is 0. नहीं, we have just done the n plus 3 and the plus 3 separate, Ritu. Plus 3 separate. What I have done in the previous question, 2 by 3 power n plus 3 u of n plus 3. That is how the time shifting is applied. Now, then 2 by 3 power n, 2 by 3 power 3 split it, that's it. And 2 by 3 power 3 was shifted on the other side, Ritu. Okay, just check it up. Rest everything is correct. This is HN. Acha, whether it is a FIR filter? See, design of digital filters is removed, but basic understanding of filters as an engineering background, it is always expected. What is FIR? FIR means finite impulse response. FIR is known as finite impulse response. FIR is known as the finite impulse response. Impulse response whose length is finite. Okay, the length of the impulse response LH should be finite. Here what is the LH? The length of H, 4. The length of the signal is 4. Actually 2, but origin ko bhi count karke chale to it is 4. Okay, it is 4. So it is finite. Yes, it is a FIR. Yes, it is FIR. So this option is true. It is a low pass filter or not? It is a low pass filter or not? So how to identify low pass filter? For that we have to check the low frequency analysis. We have to check the low frequency analysis. Now let's come to the calculation of the frequency analysis. HN, as I've told you, is 0, 0, 1, -1, where this is the origin value. Where this is the origin value, dhyan dena, 0, 0, 1, -1. So what is the H omega? The DTFT is given by the formula summation of Hn e power minus j omega n. पहला वैल्यू 0, नेक्स्ट वैल्यू 0, नेक्स्ट वैल्यू 1 एट n इक्वल टू 2 तो e पावर माइनस j 2 ओमेगा. नेक्स्ट वैल्यू इज -1 एट n इज इक्वल टू 3 तो e पावर j 3 ओमेगा. सो व्हाट इज द DTFT ऑफ दिस impulse response? e power j 2 omega minus e raised to the power j 3 omega. Put down the value of the low frequency. Low frequency is omega equal to 0. At omega equal to 0, what is the h0? So it is e power 0 minus e power 0, that is 0, right? So the low frequency gain of the system, is 0. Can it be a low pass filter? No, it is not low pass filter. It is a low pass filter if it passes low frequency with higher gain and it blocks the high frequency, then it should be a low pass filter. So it is not a low pass filter. So this is false and only statement number 2 is correct. Okay, option number A. The correct answer for the question is option number A. Only and only statement number 2 is correct. Only and only statement number 2 is correct, dear. Okay. Only and only statement number 2 is correct. Chalo, done. Okay. Only and only statement number 2 is correct. Acha, if it is not low pass filter, what it is, can we guess? Not low pass filter, that is okay, but what it is? Okay, let us check. High frequency. So when I put omega equal to pi, high frequency, I told you omega equal to pi. Omega equal to pi. So kitna hua yahan pe? H of pi. H of pi is e power j 2 omega. So e power j 2 pi minus of e raised to the power j 3 pi. E power j 2 pi will be 1. Calculate by the Euler's formula, right? Cos theta plus j sin theta, and this is going to be -1. E power j 3 pi will be -1. So net answer is 1 plus 1, 2. It passes high frequency with considerable gain. What is going to be the frequency response sketch for the system? approximately what is going to be the frequency response sketch for the system. Low frequency gain was 0. High frequency gain has turned out to be nearly 2. High frequency gain turned out to be nearly 2. This is what is the filter characteristics from 0 to pi. Okay, from 0 to pi, and that is why it is a high pass filter. It passes high frequency with more gain and it blocks the lower frequency. Okay, it blocks or it attenuates the lower frequency. It attenuates the lower frequency. ठीक है? Chalo, done. Let's move ahead to the next question then. If this part is understood to you, okay, if this part is understood to you, this is a MSQ question now. There is a system whose input-output relation is given to you. Input-output relation is given to you. Okay, now ध्यान देना. First, let me convert it into the impulse response. Input-output relation is given to you. Okay, what is going to be Hn? देखो, Yn is Xn. So Xn can be written as Xn convolution delta n. Right? Minus 2Xn minus 1. Minus 2Xn minus 1. Xn minus 1 is obtained as Xn convolution delta n minus 1. Right? Then plus Xn minus 2. So Xn minus 2 can be obtained at Xn convolution delta n minus 2. Right? Now Yn is actually given by Xn convolution with the Hn. So Xn you take common out of all, then you get the Hn. Then you get the Hn. Hn is how much? Delta n minus 2 delta n minus 1 plus of delta n minus 2. That is the Hn. Okay, that is the Hn. Or we can write down the Hn in the form of sequence also. This is delta n, origin pe value 1, then minus of 2, then plus of 1, and this is the origin. This is what the Hn is. Right? This is what the Hn is. Is it causal? Right? Yeah, it is right-sided. Yes, it is causal. Hn equal to 0 for n less than 0. Hn equal to 0 for n less than 0. It is causal. Right? It is FIR. Yes, it is FIR also. Finite in length. Finite impulse response again. Right? Whether it is high pass or band pass. No. In today's schedule, class was not there, Rajendra. Oh, I'll ask the team to check it up. But I announced in the last session also, Friday will be the next class of DTFT and DFT. Okay? So this is FIR then, guys. This is FIR as well as causal. Now band pass or high pass? चलो सर इसको check कर लेंगे whether it is the band pass or high pass. So what is going to be Hn? Hn obtained as 1, minus 2 and 1. So what is the H omega? What is the H omega? H omega is 1 into e power 0, then minus 2 e power minus j omega plus 1 e power minus j 2 omega. ठीक है dear? So low frequency omega equal to 0, right? So H of 0 is 1 minus 2 plus 1 0. It is not a low pass filter. Agreed. High frequency omega ko rakha pi. As I put omega equal to pi, what is H pi? 1 minus 2 e power j pi is minus 1 and e power j 2 pi is plus 1. So minus minus plus, तो 1 plus 2 plus 1 4. ये high pass filter होगा definitely. ये high pass filter होगा definitely, right? Whose impulse response will be something of this kind, just like the previous case only. Low frequency block किया, and up to the high frequency you will get the gain that is equal to 4. Okay. So it's a high pass. Now what are the correct answers for this MSQ question? It is a high pass filter. It is a FIR filter and it is a causal system. It is a causal system. HZ को लिखने की जरूरत नहीं. The system is causal. Yes. सिर्फ इतना लिख लीजिए option को. That itself is correct. The system is causal. Correct. A, B, D is the correct answer. Yes. The answer for this multiple select question is Abraham D. Villiers. A, B, D. ठीक है. By the convolution property, na, AKG. Okay, convolution property, xn convolution delta n is xn. Correct. Now look into this. Xn convolution delta n minus 1 is xn minus 1. For this we have solved the questions earlier also, na, convolution property. Convolution of a signal with impulse will replicate the signal. चलो यहाँ मैं बता देता हूँ. Okay, let me just mention here. Let me just mention it here, no problem. X of n convolution delta n is always xn. It replicates the same signal, or more generally, xn convolution delta n minus k will be equal to x of n minus k by applying the time shift property also. These are the properties of convolution with impulse that you can note down in case you have forgotten. In case you have forgotten, okay? In case you have forgotten. Chalo, cool. Next one, the DFT. अब देखो DFT में जाने के लिए ना, just remember this is the final, these are the final and formal formulas. Okay, for DFT, don't worry guys, DFT is a very crucial topic, and if required I will plan a marathon on it, detailed, full detail. Right now it's only question and revision session. Okay, but yeah, this question and revision session, I think it is proving very effective for the subjects. Okay, for the subjects. Band pass कैसे होगा रुफीना? See, band pass will be something like this ना. Low frequency gain also 0. Low frequency gain also 0. High frequency gain is also 0. So gain rises in between and then again falls. This is going to be a type of band pass filter ना. Low frequency पे 0 आया, high frequency पे 0 आया, then you calculate intermediate frequency. This is what I call it as IF, intermediate frequency, pi by 2. We calculate at center frequency. Okay. Chalo, yeah. So DFT, if required, we will plan one separate dedicated marathon session. Okay, so that you completely learn DFT. It's an important topic for you. Okay, but yeah, right now as a part of this curriculum, I think this champion series and the different topics with questions and revision we are taking, it is helping the students. So let us continue. Quickly we will solve the questions also of DFT, and later on when required I'll plan a complete 3-4 hours only DFT, because DFT giving you a short question, at least for EC it is giving you a short 2 marks question, and good question देता है यहाँ पे, ठीक है. But yeah, right now let's do it up. Okay, because we have included as the part of the program. So consider a finite length signal having length n. Having length n matlab signal is only there between 0 to n minus 1. Outside this signal, outside this portion, signal will be 0. Okay, how do you define the endpoint DFT? I will tell you the simple method to remember the formula. आपको केवल क्या करना है? See, what is the DTFT? What is the DTFT? Summation of the xn e raised to the power minus j omega, and that is very simple. We have remembered this already. Okay, that is very simple. Here n is generally minus n to n. Okay, right. Now omega is a continuous variable in general. Okay, now I define discrete frequency. Omega is a continuous frequency. Now let us define a discrete frequency. Sir, why we define a discrete frequency? I'm telling you na, that much of details when we want to clear everything about DFT, I will take a separate session. I'm announcing it clearly. After some time, not immediately. Let the champion series be over. Next week in the champion series, I'm coming with yet another EMT. Actually, very important EMT bhi aayenge hum. Okay. Okay, Ritu. Okay, great. So let us define a discrete frequency, and discrete frequency is obtained dividing omega, the total frequency omega. Okay, the total, let me understand right. The total frequency range of omega. Omega is a continuous variable spread over the period of 2 pi. Okay, we divide it into n points because n is the length of the signal. Okay, अब हम जो signal xn consider करने वाले हैं, that is finite length. Okay, now let the signal xn be finite length where the length is n. So we divide the frequency also by n and take it as multiple of 2 pi by n. Thank you, Rufina. Yes, Ravi, we'll plan that also. So many things in the head. Okay. Okay, Prakash, all the very best for your future endeavors. Thank you for your appreciation, and good that you have got some success. Keep getting more success. Okay, 2 pi by n into k, where k can be anything from 0 to n minus 1. Matlab this discrete frequency starts from 0, then you have 2 pi by n, then you have 2 pi by n into 2, then you have next multiple of 2 pi by n, that is 2 pi by n into 3, and etc, etc, etc. Okay, now put down the discrete frequency in the formula of DTFT, and the signal length is n. I told you signal length is n, matlab signal is only concentrated between 0 to n minus 1. So what should be the summation? Ye bhi dekh lijiye, what should be the summation, right? So now I have x of omega k. Now omega k depends on what? X of omega k depends on k. N to constant hai, omega k depends on k. So this is also written as simply xk. And that is given by the formula summation of xn e power minus j omega n. Same DTFT formula, I'm just copying. E power minus j omega n, but which omega? Discrete omega. But the signal is only there between 0 to n minus 1. So summation ko bhi 0 to n minus 1 karenge, not infinity to infinity. Acha, now put down the value. This is the simplest way, guys, of remembering the DFT formula. Ye ho gaya aapka DFT formula. Okay, ye ho gaya aapka. This is what is the DFT formula, right? Okay, so eventually you can say that x of k is summation of xn e power minus j omega n. Same DTFT formula. Omega is the discrete omega. Omega is known as the discrete omega. So e power minus j 2 pi by n into kn. Omega k ka value put kar diya. How to remember omega k? How to remember the discrete frequency? So we know that the DTFT was a continuous function of omega, where the period was 2 pi. Matlab entire frequency information of DTFT is over 2 pi. So omega, there are the continuous frequencies in the range of 2 pi. Divide by the length of the signal, okay, and take the multiples of it so that you get n different frequencies. The signal has n simples, the DFT also has the n frequency, matching the length only. Okay? So ये आ गया आपका xk. This is the final way of remembering the xk. That is what I have written actually. Okay, summation xn e power minus j 2 pi by n into kn for k equal to 0 to n minus 1, and finally the IDFT formula also I have written 1 upon n summation xk e power plus j 2 pi by n kn for n equal to 0 to n minus 1. Right. We also write down this factor as the nth root of unity. In the complex numbers we study. Okay, you are already taken the placement into the hardware company. Great, Prakash. Hope you grow. Synopsys is a very good company for electronics, especially targeting hardware design. And I don't know what profile you have got, but yeah, it's good. It's good that you're in Synopsys. Keep growing, Prakash. All the very best. Okay, this is what, according to complex number theory, this is known as the cube root of unity. So e power minus j 2 pi by n, we call it as wn. E power minus j 2 pi by n, we call it as wn. Acha, especially, let me explain you this. Sometimes you have to be very specific. What is w2? E power minus j 2 pi, that is e power minus j pi. That will be minus 1. What is w4? E power minus j 2 pi by 4, or e power minus j pi by 2. Cos pi by 2, 0, minus j sin pi by 2, right? Minus j sin pi by 2, sin pi by 2, 1. This one is very important actually. W4 is the most useful value for you, that is minus j. For with respect to questions, you can remember W4 is equal to the minus j. Okay, so you have summation n equal to 0 to n minus 1 xn w power kn, written in the form of w, written in the form of twiddle factors. Yes, very correct, Ravi, coming to the twiddle factor only. Okay, right. Both the DFT and IDFT, revising the important points before I take up the question, both the DFT and IDFT are periodic with the period n. Okay, with the period n. Both are periodic with the period equal to n. Important properties: if two signals are added, DFTs are also added. Okay, time shifting corresponding to the phase term, exponential term. What type of exponential term? See, what is mod n? It is the circular time shift. Now, I hope you remember what is circular time shift or circular folding or circular convolution. If not, I will explain you with question. I am not explaining you differently here. X of n minus n mod n. This is known as circular shift. This is known as circular shift, circular time shift. When required, I will explain with the question. We are not going on this concept, otherwise it will take a lot of time. Now, what is this? If you really understand that this is nothing but x of k e raised to the power minus j omega n naught. What is a DFT property? DTFT, apply the same DTFT property, e power minus j omega n naught. But which omega? Since it is DFT, so which omega will come, sir? Which omega will come? Discrete omega will come. Discrete omega is known as omega k, right? So now this will become e power minus j. Discrete omega is given by the formula 2 pi by n into k and into n naught. Yahi aa gaya. Everything followed by the DTFT, the life becomes simple. Time shift, exponential term. Exponential term aa gaya, e power minus j omega n naught. But which omega? Omega k. And then always remember omega k. Yes, Prakash. Thank you once again for your appreciation. Great, all the very best. God bless you. Keep growing. And next one, frequency shifting. This is again the circular frequency shift. Frequency shift means the same exponential term, phase term in the time domain. Again, have a look into this. What is this? Whenever there is a frequency shift, there is exponential term in the time domain. So x of n should be multiplied by e power plus j. यहाँ पे minus है तो e power plus j omega n. Which omega? Sir, discrete omega. Omega k naught. K की जगह k naught आएगा ना. So now this is equal to, देखो, e raised to the power j. What is omega k naught? 2 pi by n into k naught into n. यही लिखा हुआ है ऊपर. So it is the very same property. Nothing new for you, right? Time folding, frequency folding. ये कैपिटल X होगा, I'm sorry. Time folding is frequency folding. X minus n will produce a DFT, X minus k. But what is this? What is this? What is this representation, guys? This representation is again the circular folding. What is circular folding? I again hope that you remember. If not, I will explain you with the question. This is circular fold. This also is the circular fold. So property is same. Time folding corresponds to frequency folding. Symmetry. Okay. X of k is x of x star n minus k. Okay. Which suggests that we need to compute only half of the DFT value to find the entire DFT sequence. How, sir? Understand here. How this is there? Okay, suppose you have a length of n equal to 8. Okay, according to the property, what is the property I have told you? X of k is x star n minus k, right? Okay, now apply with k equal to 5. X of 5 is x conjugate 3. That means if you have already calculated up to x3, you can directly calculate x5. But how? Through a conjugate relation. Okay, then put down. Okay, ये हो गया k equal to 5. Now put down k equal to 6. So x of 6 is x star 8 minus 6. n की जगह 8 रखा है यहाँ पे. That is x star 2. So if somebody has calculated x2, so x6 is also there. Just take the conjugate. So you need not calculate that again. It is already there for you. Similarly, when you put k equal to 7, ये तो just repeat है. Okay, when you put k equal to 7, okay, it is 8 minus 7, 1. So x of 7 is x star 1. So you have calculated x1, just take the conjugate, you get x7 also, right? You get the x7 also. So that means you have to only calculate up to n by 2. Remaining values are automatically computed by a conjugate sign. Okay, so we can say that this arrow at the n by 2 is acting as a mirror. Which mirror? It is acting as a conjugate mirror. This is acting as a conjugate mirror. Let me write down. This is like acting as a conjugate mirror. Not a simple mirror. Simple mirror will create the reflection. So this is reflection but with a conjugation. Whatever is there on the left hand side, take the conjugate, you get the right hand side. Okay, take the conjugate, you get the right side. Okay, right, and the signal is only from 0 to 7, इसलिए there is no image of 0. It is alone. ये separate रहेगा. We shall take the questions also on this. Okay, we shall take the questions also on this. So compute up to the n by 2. compute up to the n by 2. Acha, this is one point to be specified. This property is there for real signals. This property is there for real signals. Now symmetry, similarly some regular symmetry property that you have in every Fourier transform. Signal is real and even, Fourier transform is also real and even. Signal is real and odd, Fourier transform is pure imaginary and odd. Fourier transform is pure imaginary and odd. Okay. Next one, convolution. Now because the signals x1 and x2 are periodic, DFT, IDFT are both periodic, and for periodicity you apply circular convolution. And again, in case you have forgotten, we will revise with the question. I will not talk about circular convolution separately, but we will revise with question. So convolution in time is multiplication in frequency. Multiplication in time x1 and x2 n is convolution in the frequency domain. Circular convolution 1 upon n, x1 ke circular convolution x2 ke. Right. Chalo. Central ordinates, very important property. Central ordinates, very important property. Nothing, when you calculate the value of DFT at k equal to 0, like omega equal to 0, sum of series property, na, you get summation of xn. Okay. And n by 2 रख के देखो ओमेगा के कितना आया 2 pi by n into n by 2. यहाँ पे what is the omega k here? 2 pi by n into k, which is 0. So this is the 0 low frequency case, right? Here what do you get? Pi. What is the pi? High frequency case, isn't it? What was the high frequency result? Summation minus 1 power n xn. Summation of the minus 1 raised to the power n xn. Okay. So this is derived using the previous case only. I will better elaborate and write down this result. So what is the first result? The signal is only from 0 to n minus 1. So it is x0 summation of all values of xn. x0 plus x1 plus x2 up to last. And this is minus 1 power n xn coming up means alternate plus minus we already discussed. So this is x0 minus x1 plus x2 minus x3 and etc etc etc. Duality xn having the DFT xk, right? X of capital X of n will have the DFT n x minus k, and minus k here again will be circular folding. Although not much important for DFT. In the CTFT, duality property is very important, but in DFT it is not really important. Now Parseval's relation, summation mod xn square, energy is given by the formula summation mod xn square, that is also equal to 1 upon n summation mod xk square. Summation mod xk square. Okay, now let us compute this value. First of all, let us start with the question now. Okay, to explain you these properties and formula. Xn is given to you 2, 3, 2, 1. Find these values. Find these values. Okay, consider xn 2, 3, 2, 1. Find the DFT of xn. So let us focus on the DFT of xn only. Then we will go to the properties. Okay. Two, three, two, 1. 2, 3, 2, 1. Okay. What is xk? DFT we have to compute. The formula is summation n equal to 0 to n minus 1. The total length is 4. It is just a 4-point signal. So 0 to n minus 1 means 0 to 3. Summation of xn, that is summation 0 say 3 xn e raised to the power minus j. Yeah, let me directly use the w factor, twiddle factor ke format, w4 raised to the power kn. What is the w4? Already we know it is minus j. So this is summation xn minus j raised to the power kn. Okay, अब देखो, you have to only apply this formula once. You have to only apply the formula once. देखो, although this is valid for all values of k, that is k equal to 0, 1, 2, 3, but you have to only apply once. What is that once? देखो, वो भी मैं आपको बताता हूँ. Okay, first let us start with k equal to 0. So when you go to k equal to 0, now you will apply the central ordinate property. You will apply the central ordinate property just discussed. Okay, x0 is summation of all values. It is summation of all values. So what is x0? It is just summation of all values. 2, 3, 2, 1. That is amounting to 8. Right. Then k equal to 2 पे आ जाते हैं पहले, because that is n by 2. Central ordinate property को complete करते हैं. What is the x of 2? What is the x of 2? Alternate plus minus. Start with 2, then minus 3. Then 2, minus 1. Alternate plus minus you have to put. So 2 plus 2, 4, minus 4. This is 0. right? Only one calculation you are going to do, that is k equal to 1. Actually these two are simple na, isko to calculation nahi bolenge, this is just very simple. Only k equal to 1. And what is x1? See, x1 will be summation of xn minus j, k की जगह 1 रखा, minus j power n, right, from n equal to 0 to 3. तो start the first value of xn 2 minus j power 0, then 3 minus j power 1, then again 2, take the series of minus j na, it is the series of minus j power 2, and then with the coefficient 1 into minus j power 3. So what is this? Anything power 0 is 1, तो ये हो गया 2, then minus 3j, then minus j square is j square, but j square is minus 1 eventually. Minus of j cube is minus j cube is minus 1, so minus minus plus, this is plus j, right? 2 cancel, minus 3j plus j, sir, that is the minus 2j, that is known as minus 2j. But yeah, that is known as what? Minus 2j. Only one calculation. Why, sir, only one calculation? Because when I take k equal to 3, already I told you conjugate symmetry, later half ka values is by the conjugate symmetry. X of 3 is given by x conjugate 4 minus 3, that is x conjugate 1. And what is x1? Minus 2j. You have to take the conjugate of minus 2j, change the sign of the imaginary part, so it becomes plus 2j. That's it. So what is the DFT answer, dear? My DFT is obtained x of k is equal to the first value. The first value is 8, second value is minus 2j, third value आ गया 0, and fourth value is plus 2j. This is known as the DFT. This is the first answer. This is known as the first answer, dear students. Okay. This is the first answer. Now let's go to the property based calculations. Second hai, if yk is xk minus 1, find the value of yn. If yk is xk minus 1, means frequency shifting is there. So first question is done. Now let us move ahead and be ready for the second question. Y of k is x of k minus 1. So that is definitely frequency shift. What they are asking? Find the yn. Find the yn. Simple question based on frequency shift. देखो कैसे होगा simple ये. So y of n should be how much? X of k minus 1. Frequency shift, तो exponential term in the time domain. C, e raised to the power j omega k naught into n xn. Right, suppose this is k minus k naught. Okay, suppose this is k minus k naught. Okay, जहाँ पे k naught का value 1 है. Okay, that frequency shifting is by a measure of 1. So what is yn? E raised to the power j. What is omega formula? 2 pi by n. N का value 4 है, into k naught 1 into n into xn. Right, 2 pi by n, n is equal to 4. So what is the yn? Sir, it is e power j pi by 2 n xn. Okay, this can be written as e power j pi by 2 whole power n xn. What is e power j pi by 2? Cos theta plus j sin theta. Right, cos pi by 2 0, sin pi by 2 1. So what is the answer? Y of n. यहाँ पे बचा only j, तो j power n xn. J power n xn. Now xn given है, right? Okay, xn given है. What is the xn? 2, 3, 2, 1, 2, 3, 2, 1. Right? ये आया j की power 0. Okay, j power n, तो corresponding j will multiply ना, j की power 1, j की power 2, j की power 3. Done. So what is yn, guys? Closing the answer here. What is yn? J power 0 तो 1 हुआ, j power 1 is j, so next part is 3j. Then j square is minus 1 तो minus 2, j cube is minus j, तो ये आ गया minus j. That's it. This is the yn. Question based on property. Third question क्या बोला है इनने? Find the DFT of yn equal to x minus n. Okay, circular folding. Third question, y of n is equal to x minus n. Okay, and for periodic signals, fold means definitely circular fold. DFT में जब भी fold बोला, it is circular fold. Now इसका DFT निकालना है, right? So the DFT of yn is known as yk, and if a signal is folded in time domain, it is also folded in the frequency domain, and that is given by x minus k. That is given by the formula x of minus k. Right? That is given by the formula x of minus k dear. चलो डन. x of minus k, अब इसको सिंप्लीफाई कर लेते हैं. What is x of minus k? We know what is xk. We know what is the xk. Xk first question answer. What was the xk? 8 minus 2j 0 2j. 8 minus 2j 0 2j. Right. Now guys, remember what you have to do is x minus k, and again x minus k in the DFT, because you talk about periodic waveforms, periodic signals, always circular folding is to be applied. Now how do you do the circular folding? We all know regular folding, regular time folding. Circular folding, guys, I'll tell you the direct method. We don't have the time to discuss up how circular folding comes. That I'm telling you, for DFT I can take a separate full-fledged marathon, but abhi method pe aate hain. Circular folding is to be done about the mirror. And where do you place the mirror? Mirror is always placed at the central value n by 2, और यहाँ पे n by 2 2 हो जाएगा. n by 2 2 हो जाएगा, right? The values of k here is 0 1 2 3. So mirror is placed at n by 2. Okay, and then you separate out the first sample and take the mirror image of the remaining samples around the mirror. Okay, mirror image matlab these two will be swapped, right? So what is going to be x minus k? Y of k is x of minus k. What is the x of minus k? 8 as it is. Minus 2j and plus 2j imaged. So यहाँ पे right wala left, left wala right, image of each other. So 2j comes here, then mirror as it is, and minus 2j goes on the right. So mirror is like the n by 2. Like in the normal time folding, you place the mirror at y axis. Here the mirror is at n by 2 always. Mirror is at n by 2. Mirror is at n by 2. ठीक है? For example, चलो मैं एक आपको separate question बोलता हूँ. Okay, एक आपको मैं separate question बोलता हूँ. Not here. इस पे आते हैं ना. Let me take an extra slide first of all. Okay. Suppose quickly, just try this. Suppose I give you xn is equal to what is x minus n equal to? What does x minus n? So I'm asking you a simple circular folding question. A circular folding question. X minus n. So what should be the answer? तो देखो क्या करेंगे. I will again place the mirror at, यहाँ पे total length कितना है? n is 8. So what is n by 2 is equal to 4. n by 2 is equal to 4. Okay, so we start the count with 0. 0, 1, 2, 3, 4. ये रहा 4. ये रहा 4. Right. So this is the mirror. This is the mirror. This is the mirror. We place the mirror at 4. Okay. And we always separate the first sample. We separate the first sample. So what is the answer? देखो. X of minus n. First sample as it is. Then. Okay, then you have to swap this 3 and 1, minus 1 and 4, 0 and 11. Left goes to right of the mirror, right comes to the left. Okay, and 11 comes here, then 4, then 1. जो जितना right की तरफ है उसको उतना left में कर देंगे. तो 11, 4, 1. Then you get your mirrored value. Okay, and then after that, then 3, then minus 1, then 0. This is the answer. I hope now circular folding is even more clear. Let us go back to the question. Let us go back. We have done the circular folding on the DFT, or also eventually in the question. Okay, sir, the next question is find the DFT of Xn circular convolution Xn. This is a question on circular convolution. So guys, fourth part coming up. That is very simple actually. The fourth part is Yn, that is equal to X of n circular convolution X of n, right? This is circular convolution. But circular convolution इस क्वेश्चन में करना नहीं है. You don't have to do the circular convolution. देखो y of n is equal to xn circular convolution xn. So its DFT y of k will be x of k. Convolution in time is multiplication in frequency. Convolution in time is multiplication in frequency. So it is xk into xk, and xk into xk is x square k. Xk into xk is x square k, and what is the square of xk? So xk was 8 minus 2j, 0 and 2j. That was xk na, to sabhi ka square le lo. Square up individual value. So your answer for this question, this one is pretty simple. 8 square 64 minus 2j, 4j square minus 4, 0 and again 4j square, which is minus 4. Okay, 64 minus 4, 0 minus 4. That's it. This is done. So this was a very simple question. Now fifth question they are asking is, what if yn is equal to x square n? Now yn is equal to x square n represents xn into xn, and that is multiplication in the time domain. So what is going to be yk? It is given by the formula 1 by n. Multiplication in time is convolution in frequency. So this corresponds to circular convolution. Now how do you do the circular convolution? I will tell you the procedure directly. Understand here. This is given by 1 by 4. What is the answer of circular convolution? Let's learn here. Guys, learn the answer of circular convolution. Xk with itself. Acha. What is xk? 8. 2j minus 2j, 0, 2j. Right. What I will do is, first, the same tabular method, same tabulation method, sum by column method. Place 8 minus 2j, 0, 2j. Place one of the signal on the top, another signal on the side. 8 minus 2j, 0 plus 2j. One of the signal on the top, one of the signal on the side, and multiply 8 with all elements on the top. Multiply 1 by 1. 8 8s are 64. Then 8 into minus 2j, 8 into 0, 8 into plus 2j. Now multiply minus 2j with every element on the top. And whenever you do the tabular method, whenever you do the sum by column method, when you multiply by minus 2j, you start the answer from next. 1 unit right shift. Then you start the answer from here. Next you start the answer from here. Just pay attention. One small change. अब आप क्या करोगे? Minus 2j into 8, minus 16j. Minus 2j into minus 2j, 4j square, minus 4. Minus 2j into 0, 0. Now very carefully, minus 2j into 2j, this is 4j square. This is minus 4j square, which is actually plus 4. Ye plus 4. But in the DFT, always your boundary is between 0 to 3, 0 to n minus 1. So if anything is going outside 0 to n minus 1, if anything is going outside 0 to n minus 1, circular folding is to be applied. So what you will do, this 4 has to be brought here. This 4 has to be brought here. Circular folding. Okay. Next, understand the next calculation one more time. Now I multiply by 0 and start writing the answer from here. One more unit right shift. So 0 into 8, 0 into minus 2j, again 0 and again 0. Okay. Although here it is 0, but whatever is there on the right, bring it here. Next, this is how circular folding is done. Next, 2j multiplied by 8, 16j. 2j multiplied by minus 2j will become plus 4. 2j into 0, then 2j into 2j, minus 4. But whatever is there on the right, circular fold, and it has to be written here on the left in the same sequence 4, 0, minus 4. In the same sequence 4, 0, minus 4. Okay? Now add every column. Now apply the sum by column. So when you add here 64, 4, 4, 72, then ye ho gaya minus 32j, then minus 4, minus 4, minus 8, and this is total 32j. I will go and write on the previous slide. My answer is 1/4 of this calculation, that is 72 minus 32j minus 8 plus 32j. Okay, take the 1/4 of all of these numbers, so your final answer is equal to 18 minus of 8j minus of 2 plus of 8j plus of 8j. Okay, done hai guys. So this is what is circular convolution technique also. Okay, simple MCQ question. First 5 points of 8-point DFT of a real valued sequence are given to you. Okay, last 2 points. Okay, sorry, first 6 hai, not first 5. First 6 points are given to you. Find the last 2 points. You have 5, 1 minus j3, 0, and then 3 minus j4 and 2 plus j4. 1, 2, 3, 4, 5, and then 3 plus j4, and then question mark, and then question mark. Find the last 2 points. Actually first 5 points dete to bhi chal jata. Okay, we need only up to n by 2. We need only up to n by 2. This is the 8-point DFT. N ka value 8 hai. So what is n by 2 is 4. 0, 1, 2, 3, 4. This is my conjugate mirror. We have the conjugate mirror at n by 2, right? And the role of the mirror is to create conjugate reflection, conjugate symmetry. 3 plus j4, 3 minus j4. Yeah, this satisfies, right? So what is this question mark? It should be conjugate of 0. This should be 0 conjugate, which is 0, right? And then one more conjugate relation. What is the next question mark? It should be 1 minus j3 conjugate, and 1 minus j3 conjugate is 1 plus j3. It is 1 plus j3. Correct answer is B, 0 and 1 plus j3. Very simple question. Property based question. MCQ, 0 and 1 plus j3. Option number B it is. Chalo. Next question, it's not specified. This is also a GATE question, but just one message I want to show you from here. Okay, most of the champion series we haven't taken GATE question. Almost 90% questions are fresh. 5-10% हमने कभी-कभी GATE का ले लिया है, just to explain you what is this concept now. Okay, xn is given to you 3, 2, 3, 4. What is x1n? What is x1n? 3, 0, 2, 0, 3, 0, 4, 0. Zero padding is there. That means it is the same value. 3, 2, 3, 4. In between zeros have come. Means this signal is expanded. This value 2, 3 times shift ho gaya. Right. Again, this goes to 6. It is an expansion of the case. It is an expansion of the signal. So what is this signal x1n? The signal x1n is the same signal xn but expanded by a factor of 3. Expanded by a factor of 3. Okay, this was n equal to 0, 1, 2, 3. So the value which was at 0, it remains at 0. Then 1, 2, 3. 1 wala value 3 pe chala gaya. 2 wala value 6 pe chala gaya. 3 wala value 9 pe chala gaya. Means expanded by a factor of 3. X of n by 3. Good evening, crocodile. Okay, it is x of n by 3. So one last point I want to tell you here is ki what is the DFT of xn by 3? Dekho. Understand like this. If xn has the DFT xk, what is the DFT of xn by 2? Scaling property, I'm just going to tell you, interpolation scaling property here. This is given by xk repeated. Right? X of n by 3 will have the DFT xk copied 3 times. xk copied 3 times. Similarly, if it is xn by 4, then it is repeated 4 times. Okay, thank you crocodile. Okay, यहाँ पे xn/3 है. Okay, so we have x1n is x of n/3. Okay, so what is its DFT x1k? Its DFT is going to be xk replicated 3 times back to back. So your entire DFT, this is additional property I am telling you, xk copied 3 times, xk given hai, xk is given to you 12 2j 0 minus 2j, 12 2j 0 minus 2j, copy again 12 2j 0 minus 2j, copy again 12 2j 0 minus 2j. Got it? Okay guys, chalo. Do not forget to like the session. Keep liking the session for all the efforts that BYJU'S Exam Prep is putting for you. Now we need the value of x1 8 upon x1 11. अब अगर k का value लिख दें, k, this is 0 1 2 3 4 5 6. We need 7 8 9 10 11. We need the value at 11. We need the value at 8. हमें चाहिए 8 वाला value, 11 वाला value. We need x1. What is there in the numerator? x1 8 by x1 11. 8 पे जो वैल्यू है 12 डिवाइडेड बाय माइनस 2j, टेकिंग द मॉडुलस 6j का मॉडुलस, आंसर इज 6. Okay, so one more interpolation property I wanted to tell you, and I have told that answer is 6. Rest guys, if you really want a detailed session on DFT, I will bring up a marathon for you after this champion series. Okay, because this is one topic where I feel, you know, if you have not studied comfortably earlier, only questions will not help you. You need to learn the concept, you need to learn techniques. Okay, yeah, those who have studied once, this is okay. DTFT, CTFT, Laplace, वो सब तो question के through we have done it comfortably, right? That is time scaling, Ravi. Okay, will if you don't not clear with the basics, I'll take a separate session, Ravi, don't worry. Okay, so time is 10:30 guys. Let's stop here. Let us stop here, but before that, let's fix up the PDF password for today's session. PDF you will receive in my Telegram group. The password is going to be, I have randomly thought the password, and password is DFT. We will keep the today's PDF password is DFT. Those who are watching the session maybe right now or later on, those who watch, they get the password. Rest cannot access the PDF without the password. The password is DFT. Very simple. Okay, that's it guys. And now next subject you are going to meet me in the champion series is EMT, starting from next week. Right now from tomorrow, Fanindra sir is going to start the control systems. From tomorrow, Fanin sir is going to start the control system at the same time of 9 p.m. Yes, at the same time of 9 p.m. Correct. Yeah. Fanin sir is going to start the controls tomorrow 9 p.m. Okay guys. With this I'll sign off. Bye bye. Thank you. Stay safe. Take care. See you in the EMT champion series. EMT next week se aayega. Okay. That will be next week after control systems. Right now enjoy control systems by Fanindra sir at 9 p.m. Okay, and do not forget to like the session. In case you haven't liked the session, show your love. We'll see you again. I'll also energize myself and see you once again in the EMT classes of champion series. Good night. Stay safe. Take care of yourself.